Alright, the second subtopic, which is on Young's modulus. So in this subtopic, you should be able to define what is Young's modulus, discuss the strain energy from force elongation graph, discuss strain energy per unit volume from stress strain graph, and then lastly solve problems related to the Young's modulus. Okay, so Young's modulus is actually defined as the ratio of the tensile stress to the tensile strain if the proportionality limit has not been exceeded. Okay, if it has not been exceeded, baru it is known as the ratio, baru it can be classified as Young's modulus lah. Okay, so Young's modulus symbol is gamma, and then the formula is shown here lah. Okay, where tensile stress is just the perpendicular force over the cross-sectional area, and then tensile strain is the elongation over the original length. Okay, so rearrange that, you then get the formula for Young's modulus. So this is a scalar quantity with the unit of kilogram per meter second square, or Newton per meter square, or Pascal. Okay, so Young's modulus does not depend on the length of the wire, but it does depend on the wire's material. Okay, so Young's modulus is affected by the type of material of the wire, and then it does not change if the length of the wire is increased or decreased. So Young's modulus is not affected by the change in length lah. Okay, so the table below is showing us the value of the Young's modulus for various types of material. For example, aluminium is 69, and then the rest lah. Okay, so this is the relationship between force constants and the Young's modulus. So from the statement of Hooke's law and the definition of Young's modulus, we can see that the force constant is affected by the Young's modulus, and then ini Young's modulus I'm gonna change this to gamma lah. Okay, so a greater value of Young's modulus will cause a greater value of force constant, meaning the material will be stiffer lah. Okay, and then a stiff material more nearly maintains its size and shape under a load in the elastic regime, and then stiffer means stronger atomic bonding lah. Okay, so in order to separate them, a greater force must be used lah. Okay, so basically Young's modulus is telling us about the stiffness of a material lah. Okay, so if you look at this table, the material steel is the most stiff lah. Dia paling stiff among these materials shown here lah. Okay, alright, okay, next is on strain energy. So strain energy formula, that you just have to know the formula. The part here is basically the derivation lah. Okay, so strain energy can be calculated by using this formula here. So the work done, how do we calculate the work done, which is the strain energy lah? It is by using the force against extension graph, where we integrate it in terms of the extension lah. Okay, alright, that is that. You just have to know how to use this. And then we have strain energy per unit volume. So it is the area under the stress strain graph only up till the proportionality limit lah, similar to this one. Okay, and then so basically strain energy is this, and then we relate it with the stress and then also with the strain. We then get the strain energy per unit volume punya formula to be this one here. Alright, okay, alright, so that is basically the theory part for subtopic 11.2, which is Young's modulus.